Hi, in this video we're going to learn about graphing linear equations. So what we're going to do is we're going to start with slope-intercept form, which is the easiest way to graph. Slope-intercept form is right here, y equals mx plus b. If you can get a linear equation in two variables, x and y, x being the independent variable and y being the dependent variable, then and it's in this form, y equals mx plus b, if you can get it in that form, then all you need really is this m, the slope, and this b, which is the y-intercept. Y-intercept meaning the point where it crosses the y-axis. So that point will always be have the x value 0 and then the y value of whatever that b value is. So when I said independent and dependent variables, this just means that like in a real world scenario, let's say that you're selling t-shirts and the t-shirts cost a certain amount plus a base cost. This x would be the number of t-shirts that you sold, and the y would be the cost because it depends on how many t-shirts you sold. So in a linear equation, x is your independent, that's what changes, and then y will depend on that. So a lot of times we see that in terms of cost, the number of items sold or whatever. Okay, so we need to figure out this slope and this y-intercept. So if you can solve an equation for y, then graphing is pretty straightforward. What we want to do is first look at this b. We want to identify what that is and identify what this m is. So in this case, we're going to find our m and our b. This is already solved for y. If you need more practice solving for y, you can look back at that first video that I posted where you're trying to isolate a variable. So we need to isolate y by performing inverse operations. And these examples, I've already got that done for us so that we can focus on the graphing. Our slope here is 2, and our y-intercept is -3. So notice that on slope is how steep a line is essentially. So it's how much you're rising divided by how much you run. So basically how much you're going up versus how much you're going over. So it's the steepness. We look at it as rise over run, so this is a fraction, so it's actually okay if this slope turns out to be a fraction. It's really easy to address. So I'm going to actually make this a fraction to make it easier to perceive as rise over run. So this 2 is going to be my rise, and my 1 is going to be my run. So the first thing that we want to do is plot the y-intercept. All right, so this y-intercept is -3, that's where it crosses the y-axis. So on my y-axis, I'm going to go down to -1, -2, -3 right here. And then from the y-intercept, I'm going to use my rise over run to find the next point. I'm just going to kind of put this in a little bubble here so it doesn't get confused with everything else. So after I plot my y-intercept, I'm going to use this rise over run to find the next point from that y-intercept. Now I know that this point is a point on that line. So from here I want to find another point. The slope is 2 over 1, so what that means is I'm going to rise 2 and run 1. To keep consistent, run means go to the right. So as we go up, we're going to run to the right. If the slope is negative, which we'll see later, we'll address that by going down. That will be addressed with the rise instead of the run. So we're going to rise 2 from this point. We're going to go up 2 and run 1. So run means to the right. And then that's where another point is going to be. We actually only need 2 points to define a line. So that's all we need. There may be sometimes we're going to see this with graphing systems of linear equations where it's helpful to have more points just to kind of get your line set where you can see additional points on that line. But for the purpose of just graphing, and when you go into Alex to do this, it'll plot the line nice and neatly for you, so you will only need those 2 points. So we're going to go ahead and connect those, and that's it. That's my line. So if you have this in slope-intercept form, graphing is pretty straightforward. Plot that y-intercept, and then use that slope, rise over run, to find the next point. Here's an example of one where we have a negative slope, so it's -2 over 3. It's also fractional. And then again, that's your m value, and then your y-intercept is 1, our b value. Again, this is fractional, which sometimes I think we shy away from fractions because they tend to be harder to do calculations with. But when it comes to graphing and slope, it's fine because we're dealing with a rise divided by a run. So we're just counting the numerator and counting the denominator. The first thing we're going to do is plot that y-intercept. So b equals 1. Again, its square crosses the y-axis, which is this vertical axis. So we're going to plot there. And then our slope is negative 2 over 3. Some of you may think, okay, so that negative is out front. Which one does it go with? But that's why I was saying we just attribute that to the numerator. We'll take that negative to go with the numerator so that we go down. So our rise is negative, meaning we go down. So from this point, we're going to go down. Rise is negative, down 2. And to the right, 1, 2, 3. And that is where we will plot our next point. And that's it. You can also see the direction of these lines is going the opposite. So this is going up and to the right, whereas this is going down and to the right. So you can kind of, I think once you see a lot of these, you'll kind of recognize whether there's a positive slope going up and to the right or a negative slope down and to the right. The only other thing about graphing that I thought might come up as a question is function notation. Function notation just means f of x. So this is a function of x. This is basically interchangeable for y, where we can just look at this as that equation, and that it's just f of x. We're going to look at that a little bit more in a later module, but for the purposes of this section, that just means it's a function of x. So what we're going to do is we're going to determine again what the slope and the y-intercept are. So the slope on this one is 1/5, and our y-intercept is 5. So again, we're going to plot that y-intercept first, go up 1, 2, 3, 4, 5. I'll do this one in red. And then our our slope is 1/5. So from this point, we're going to go up 1 and to the right 5. So rise 1, run 5. So up 1 and then over 1, 2, 3, 4, 5. And that line is not as steep, forgive my kind of crooked line there, but that line's not as steep because it's got a very small slope. 1/5 is a very small slope. All right, so that's graphing. When you have slope-intercept form, so there may be a time where you don't know what the slope is. Maybe you're told that there are 2 points on a line, and you don't have an equation for that line, you don't know what the slope of that line is. So if you're asked to find slope, given 2 points, so find the slope of the line passing through the given points. So let's take point 2, -1, and -3, 4. All right, so if we want to find the slope of the line passing through those 2 points, there is a formula that we can use to find slope, and that formula is m, again that same m value that we just saw, is equal to rise, which is the change in the y value, so that's y2 minus y1, the first y value, the first y from the point minus the second value. The direction of that doesn't actually matter as long as you're consistent with this denominator, which would be x2 minus x1, since that is the change in the run going from left to right. So this is the change in the rise over the change in the run. When I mentioned being consistent, if you make this your x1, y1, and your x2, y2, so this is your first point, this is your second point, your x sub 2, denoting that that's the x from your second point. Just be consistent in the formula. If you're starting with -3 down here, then this needs to be the 4. It can be the other way around. You could make this your x2 and y2, but just be consistent with keeping the points together like that. So in this case, what we're going to do is just plug into the formula. So you have a point here, you have a point here, just take those y values, take the difference of them. y2 minus y1 would be 4. Be careful with the negatives. This is 4 minus a -1. And then down here we have x2. So since we started with the y2 up here, we need to start with the x2. So this is going to be -3 minus the x1, which is 2. So I'm simply plugging into this formula from the points that I'm given to solve for slope. Minus negative, that's going to become plus a positive. So that's 4 plus 1 or 5. over, and then negative 3 minus 2 is a negative 5, and 5 divided by negative 5 is a negative 1. So your slope in this case is a negative 1. So that is solving for to find the slope of a line between 2 points. All right, from here, what we're going to do is just look at a couple more examples of graphing. And I'm going to kind of just show you one example of a couple of things here. Graphing using, by finding the x and y intercepts. Now, I mentioned that you only need 2 points to graph a line. So if you can find the x-intercept and the y-intercept, again, which means where they intercept the x and y axis, where they cross the x and y axis, if you can find those 2 points, then you have enough points to graph the line. So what we're going to do is just look at an example of one like this. We have 3x minus 2y equals negative 6. Now, we already looked at how to graph this using slope-intercept form. You would have to solve this for y, isolate y by subtracting 3x and then dividing both sides by negative 2. We could certainly do that and solve using slope and intercept. But in this particular one, I'm going to be able to graph it by using the x and y intercept. And what that is, to find the x-intercept, if you think about the coordinate plane, x-intercept is here. No matter where you are on that x-axis, y is always 0. So you don't know where it crosses the x-axis for your x value, but you know that when it's crossing the x-axis, that the y value has to be 0. So we're going to plug in 0 for y and solve. And then for your y-intercept, you might guess already, it is the opposite. If you think about your coordinate plane, your y-intercept, no matter where you are on that axis, your x value is going to be 0. You didn't go over to the left or right any, your x value is going to be 0. So for these, we are going to plug in 0 for x and solve. All right, so we're just going to take this equation and plug it directly in. So we have 3x, minus 2y equals negative 6. I'm going to take 0 and plug it in for y. So I've got 3x minus 2 times 0 equals negative 6, and then just solve for x. Because we have that value for y, we can solve. So we're going to have 3x, this is just 0, so 3x equals negative 6. And then dividing by 3 on both sides, we're going to have x equals negative 2. So that means that the x-intercept, x is negative 2 when y was 0. So that's the ordered pair that you would graph for this line. Over here, we're going to do the same thing, but with the x value, we're going to plug in 0 for x to solve for y. So we have 3 times 0 minus 2y equals negative 6. 3 times 0 is 0, so just bring down this negative 2y. Don't forget that negative there. That is attached to the negative 2y. It doesn't go away. Equals negative 6, and then divide both sides by negative 2 to solve. Then we'll get y equals 3. So when x was 0, y was 3. And these are the 2 points that you could plot on a coordinate plane to figure out, or to graph that line. That's all you need, are those 2 points. And that's it. Now there are some cases where you may graph and you may want to find the x and y intercept, and there's only one x and y intercept. It might be 0, 0. So if you solve to find the x and y intercept and it's 0, 0, the point is 0, 0, then you would have to find another point in the line. So that is an exception to that rule to find the x and y intercept. If you get 0, 0 for both the x and the y, then you would have to find another point on that line. All right, so I'm going to show you just a couple of other things on graphing lines, and then we will wrap this section up. One thing that we want to look at is we've looked at how to graph using x and y intercepts. We've looked at graphing using slope-intercept form. One way that we haven't talked about is by just using a table. This is a nice way. It's not the most efficient way, I think, especially if it's in slope-intercept form. That's the easiest way to graph. Remember, in this case, f of x just means y, so we can kind of just look at it that way. It just means that we're looking at a function of x. What we're going to do is we're going to plug in a table, an xy table, and we're just going to pick any random points that we want. We can pick some values for x. We can try -1, 0, and 1. I'm going to pick a few. I always encourage you, even though we only need 2 points in a line, if you do use the table method, it's a good idea to use more than one, because if you make an error plugging in, you'll catch yourself if you have more than one line, because it won't actually make a line. So if you make an error and there's not a line, then you'll know that something went wrong. So I mentioned earlier that x is the independent variable, so I'm just making up values for that because y depends on that. And once I come up with those values for x, again, it can be anything, then I'm just going to take those and plug it in to this equation. So it will be 2 times -1 minus 1. So I'm just taking that -1 and plugging it in there, which is equal to 2 times -1 is -2, minus 1 is -3. And then I'll carry this out a little bit further. If I take 2 times 0 minus 1, that'll be 0 minus 1 equals -1. And then plug in 1, 2 times 1 minus 1 equals 2 times 1 is 2, minus 1 is 1. And then I have 3 points that I can graph on a line. Again, I only need 2, but it's good, especially when you're using a table, to have a few more, or at least one extra one to make sure that you did your calculations right. So we have the ordered pairs, -1, -3, 0, -1, and 1, 1. Whoop. So 1, 1. And we're going to plot those and they should make a line. Again, if they don't, then that means something went wrong over here. So -3, -1 would be -1, -3, -1, and then -3 down here. 0, -1 would be here. And then 1, 1, go to the right one, and up 1 would be right here. And there's your nice little line. The only other thing I want to mention is that vertical lines are in the form x equals a constant, and then horizontal lines are in the form y equals a constant. And just to kind of show you why on these, just a little example here, and I'm not going to get real specific on this, I just want to explain a little bit of where this comes from. If you notice, we have the x and y axis. If you take a vertical line, it's going to go somewhere vertically through that x-axis. Notice that no matter where you are on that line, if I graph that line, x is always the same value. So whatever that k value is, in this case, it's right here, whatever that x value is that it's crossing through, that value is going to be the same for x across that whole vertical line. Likewise with the horizontal line, no matter where you are on this horizontal line, y is always going to be the same value. So for example, if you have y equals -1 and you want to graph that, then you're just going to have it go right through -1 right there. And that would be your horizontal line. And that just means that no matter where you are on that line, y is -1. X is changing, but y is always -1. So that's just a quick note about vertical and horizontal lines. And that's it for graphing lines.